For Chapter 17, we're going to be getting into some geometry. For this first section, I'm going to just be kind of going over some of the basic ideas that you need to know of what makes up geometry before we get into different shapes. And then when we get into the shapes, we will be talking about perimeter, area, volume, all of that kind of stuff. For this first section, I want to start off by just going over some of the basics of geometry. So this is going to be a lot of vocab that you just need to know, and if you remember stuff from your geometry days, then this should be fairly review for you guys. It shouldn't be anything super new, and it's just going to kind of go over some of those words that you need to know so that if a problem is talking about one of these things, you know exactly what they mean. So a point would be a location or a position, and it has no size or dimension. So a point would just be talking about where something is at. And a lot of times when we look at pictures, you know, they do draw a point, but just know that that point doesn't technically have a size to it. It's just representing a location or a place somewhere in the figure. A line is going to extend indefinitely, which just means it goes forever, in both directions, and it contains an infinite number of points. So lines have to have at least 2 points in order for it to even exist. But if you actually look at a line, it's going to continue to just have points, like point after point after point after point after point, forever and ever and ever. Now a line segment would be looking at a very specific part of a line. So lines have arrows on either side of them, which lets you know that they continue to go in that direction forever. But a line segment has endpoints, and so it's almost going to look like 2 points. There's going to be one on each side, and it's going to be talking about a very specific segment, so it'll have length to it that you could measure. And so those endpoints are where the line segment starts and stops. Now a plane would be a flat, smooth surface that extends indefinitely in all directions. So a plane would be like a rectangular shape, or it could be a triangle shape, or it could even be something like an octagon, or it really could be anything. But like a line, planes continue to just expand. So imagine if you have like a rectangle in front of you, and you have points and lines inside of this plane, so inside of this flat surface. If the lines continue to go forever, that plane is going to also continue to extend in all directions. A ray is similar to a line in that it is going to go in one direction forever and ever, but it does have a very specific starting point. And so it has that end point that kind of begins the ray, and then it continues to go forever in one direction. So an easy example would be like a flashlight. So when you turn a flashlight on, the way that the light shines out from the end of that flashlight would be an example of a ray. So right at where the bulb is, that's like the end point, and then where the light shines would be the example of the ray. Parallel lines would be lines that never intersect. And then getting into an angle. So an angle is formed by 2 rays that intersect at a point, and the 2 rays are called the sides, or they might also be called the legs of the angle, and then that common point that they intersect at is known as the vertex. Okay, so now that you kind of know what points, lines, planes, rays, and all that are, let's use a figure here to name some of the following. So this first one wants us to name a ray that has an endpoint of T, so that means it starts at T, and it passes through P. So if you guys can find T here on this picture, T is the endpoint, and it wants to go through P, which means it's going to go through M first, and then it's going to continue on and go through P. So one way to name that ray would just be to say TP. And notice the symbol above that TP is kind of like a line, but it doesn't have the double arrow. It just has an arrow on one side because it's talking about a ray, and a ray starts at a specific point and it just goes forever in one direction. Now, do the lines LM and MN represent the same line? So if you look at those points, they're all on that same line that's crossing through the other 2. So because all of those points, the L, the R, the M, and the N, are all on the same line, the LM and MN do represent the same line because they're all contained on that one specific line there. And that line could be named a couple different ways. You just have to pick 2 points. So you could say LR, LM, LN, RM, RN, you kind of get the point there. So you just have to name 2 letters when you're naming a line. Do PT and TP represent the same line segment? So if you look at P to T, those have those endpoints, and it's being pulled off of that line. These would represent the same line segment. Again, it doesn't matter the order that you have those letters in, you just have to have 2 of them when you're either naming a line or a line segment. So those 2 represent the same portion of that line. And last one here is name 2 lines that are parallel. So you could call the bottom one PT and you could call the top one RS. Now again, you could switch that around. You could say SR, you could say TP, or you could even say TM, MT for that other line. You just have to pick 2 points again to name a line. Let's get into naming an angle. There are a couple of different ways that we can do that. Some of the easier ways are to use a number. So if the inside of an angle is marked with a whole number, like 1, 2, 3, 4, you can use that to call the angle by that. Or you could use a capital letter. Now, kind of the caveat with the capital letter is that it can only be used if there's only one angle in the picture. So if you have a bunch of angles kind of coming off of the same point, you can't just use one capital letter, because if that capital letter is in the center and there's like 5 angles coming off of it, then if you could just call it by that letter, they may not know which angle you're talking about because there would be more than one to choose from. So in that case, you would want to use 3 capital letters. So that's used most commonly when you have multiple angles in a picture or in a figure. So, for example, this one has 1 angle in the picture, okay? And so if they wanted us to name it with the 1 capital letter, we would just call it angle X. So if you're able to use 1 capital letter because there's only 1 angle in the picture, you just use the letter that's by that vertex. That's in that kind of corner where the 2 rays come off of it. Now, if they want you to name it with 3 capital letters, you could do 2 different directions. You could do YXZ or you could do ZXY. If you want to name the angle with a number, this one would just be angle 1. In order to classify angles by their size, we use degrees. That's the unit that we use for measuring angles. A right angle is going to equal 90. An acute angle is going to be less than 90 but greater than 0. And an obtuse angle is going to be more than 90 but less than 180. Let's talk about complementary. So if you hear that angles are complementary, that means that they're adding up to 90. So if you're trying to find the complement of an angle, you subtract the measurement that you have from 90 to find the other complement of that. Now, supplementary would mean that they add up to 180. So very similar to the finding the complement. If you want to find the supplement, you subtract its measure from 180 instead. Getting into some angle relationships, the word congruent, if you hear that or you read that, it means that they're equal, so they have the same measurement. Vertical angles are when 2 lines intersect, and there are 4 angles that are created. So if you have 2 lines and they kind of form like an X when they cross, you've got 4 angles that happen there. The angles that are directly across each other are going to be called vertical angles, and they're going to be congruent. Now, adjacent angles, adjacent means next to, so they would be angles that share a common side. And adjacent angles are always going to be supplementary, which again means they add up to 180. Now, in geometry, you probably talked about a transversal. A transversal is a specific line that actually goes through 2 or more lines. And when this happens, there's 8 angle relationships that get formed. So I have this picture here where A and B are my 2 lines, and they can be parallel or not. C is the transversal, and I've got these angles measured, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so I'm going to go over what are the angle relationships that happen. Interior angles would be the angles that are between lines A and B, so 3, 4, 5, and 6. Exterior angles then would be the outside of lines A and B, so 1, 2, 7, and 8. Corresponding angles. Now this is all based off of how they relate to each other in regards to that transversal. Okay, so corresponding angles means that you have one of them is interior and one of them is exterior, and they're on the same side of the transversal. For example, 1 and 5, 3 and 7. Both of those are on the left side of that transversal line, and 1 is on the outside, 5 is on the inside, 7 is on the outside, 3 is on the inside. So on the other side of the transversal, on the right side, your corresponding angles would be 2, 6, 4, and 8. Alternate angles mean that they're on opposite sides of the transversal. So you have one like on the left side, one on the right side. Now this gets broken down into alternate exterior angles and alternate interior angles. So if we're looking at just the exterior, again, exterior angles were the 1, 2, 7, and 8. The alternating pairs then would be 1 and 8, 2 and 7. So the alternate interior angles would be 3, 6, 4, and 5. Consecutive angles would be when they're on the same side of the transversal. And again, we could have consecutive exterior and consecutive interior. So examples of consecutive exterior angles would be 1 and 7, 2 and 8. And consecutive interior angles would be 3 and 5, 4 and 6. Now, when they are on parallel lines, so when a transversal cuts through parallel lines, the angle relationships are a little bit more special, like they actually have relationships with each other. So corresponding angles are always going to be congruent. Alternate angles are always going to be congruent, and again, that's the interior and exterior. And consecutive angles are going to be supplementary. And again, you have consecutive interior and consecutive exterior. For example, if you are told in this picture that angle 1 is 120 degrees, and they ask you to find the measures of the remaining angles, you could use all of those angle pairs that we talked about in order to help you figure this out. An easy thing that you could do to kind of shortcut your way through this, if you look at the pairing 1, 2, 3, 4, those form those vertical angles that I told you about. So 1 and 4 are vertical because they're directly across, and you can see that they look the same. 2 and 3 are also vertical, and they also look the same. So 1 and 4 are both going to be 120. Now 1 and 2, and 1 and 3, 3 and 4, 2 and 4, all those angle pairs are adjacent because they're right next to each other and they share a side. That means that they're going to be supplementary. Well, if I already have 120 and I have supplementary angles, that means that they need to get to 180. So 180 minus 120 is going to be 60. So you could use that then to kind of help you fill this out. So I've got all those other angles listed here. So you can kind of go through and look at 2, 3, 6, and 7 should all be 60 degrees. 4, 5, and 8 should also be 120 degrees. And you can use the shortcut that I just kind of talked about, or you can always go back to the slide before this one and look at those angle pairs that I talked about that are on the same side of the transversal, on opposite sides of the transversal, and use the knowledge that you know about which ones are congruent, which ones are supplementary to do the exact same thing. You're still going to get those numbers no matter which method you use here. Alright, for the assignment, it's going to be on the homework website, and it does come directly from the book, so I was able to scan the problems there. So make sure that you only do the ones that I assigned. You will not have to do all of them. And make sure that you submit that to me yet still in an email, so you can either print out the paper or just write your answers on a different sheet of paper, take a picture, and send it to me. And lastly, if you have any questions or you need help, please email me. I would be happy to answer any questions that you have, or we can get in contact some other way. If you need to do like a video chat or something like that, we can do that too.